So now we are on question 6. Question 6. So question 6 is saying, so we are 6.1. A symbol of compound V contains 54.56%, right? C 9.09%, then H 5.6, C then 9.09, so 9.09, H, like that. Then from there 36.35%, or like that. So this is C, this is H, and this is O, right? Then question 6.1.1 says define the term empirical formula, right? Then 6.1.2 use calculation to determine empirical formula of compound V, of compound V, right? Then 6.2, it says when 150 grams of hydrated 150 grams of hydrated aluminium chloride, that is AlCl3, then we put a dot. That means it's a light bond. This doesn't mean a multiplication sign. It means it's a light bond. Then we say NH2O, right, is dry. Its mass decreased by 89.595 grams. So this will be another question. That will be 6.2, right? So let's answer first 6.1 and 6.12, then we'll go to 6.2. Right. So on 6.1, what was the question? Define the term empirical formula. So how do we define empirical formula? So empirical formula, we can say empirical formula is the ratio of atoms in a compound. Is the ratio of atoms in a compound, or atoms of, let's say, atoms of each element. So I'm saying it is the ratio of atoms of each element in a compound. This is what we call the empirical formula. And then use calculation to determine the empirical formula of compound V. So now let's go to where we have to determine the empirical formula of compound V. So now we are given 54.56. Alright, so for us to find the empirical formula, so C, we know C is carbon, so carbon it has 12 mole per gram or gram per mole. Then hydrogen we know that it is 1 mole per gram, alright, like that. Then oxygen 16, like that. So now to find mass, right, so we say mass equals to mass. For us to find the mass, we say percentage given over molar mass, right? This is the formula that we are using, percentage given over the molar mass. So now for carbon, if we are starting with carbon, or let's start with, yes, carbon 54.56 over, we said carbon is 12, like that. Then let's go to hydrogen. So for hydrogen we're saying 9.09 over 1, right? So we say 1 mole per gram, then equals, then we leave some space for the calculation, for the calculator. Then oxygen, so this is carbon and we say this is hydrogen, then we are going to oxygen. So for oxygen we are saying 36.35 over the molar mass, which is 16. So now we want the answers. So the answers, if we say 54.56 divided by 12, we are supposed to get 4.547 moles, right? Then here we get 9.09 mole, because we are dividing by 1, nothing changes. Then there we are supposed to get something like here 16 gram per mole, right? Gram per mole. So we are supposed to get something like 2.272 moles, like that. Then from there now we want to simplify these, so let's write them. Carbon we said 4.547. Then hydrogen, we said it's 9.09 moles, right? Then oxygen we said it's 2.272 moles, right? So we take the one that is the smallest, then we divide with the smallest throughout. So the smallest is 2.272, it will be the smallest. So we are going to divide with 2.272, right, moles throughout, right? So 2.272 moles, right? 2.272 moles, right? So we cancel this, so this one into that one, we remain with 2. Here we are remaining with 2. Then there, right, there we get 4. So here we are having a 4. Then on oxygen we are having 1, because 2.272 divided by 2.72, we get 1. So now that means the empirical formula will be, right, so we now write the atoms that make the compound. So we said CHO, right? And now we want to write each of the number where it belongs, right? So for carbon, we just go and take the answers directly. For carbon, we are having 2, so that means we are going to put a 2, so that is C2. Then for hydrogen, we are having 4. As you can see, for hydrogen we are having 4, so we are going to put 4 there. Then for oxygen we are having 1, so we don't write anything. because it's the same. So that means the empirical formula is C2H4O. That will be the empirical formula. So this brings us to the end of the question.